Okay, so in this video, we're going to talk about how to find the exact value of an inverse trigonometric function. So say we're looking for find the exact value of sine inverse of 1. So pretty much we ask ourselves, what is the angle so that we have sine of that angle gives us 1. But we have to be careful that this angle has a restriction because the inverse function only exists within certain interval. So this is between pi over 2 and negative pi over 2. So whatever that angle is, it must be between negative pi over 2 and pi over 2. So we know from the unit circle that if we draw the unit circle, here's our unit circle, sine corresponds to the y-coordinate, which means that when is our y-coordinate equals to 1? Well, our y-coordinate is 1 here, so this is 0, 1. So that means what angle that is? Well, that is pi over 2, and it's within the interval we're looking at. So therefore, sine inverse of 1, it's going to be pi over 2. So pretty much that's how you would think of inverse functions. Okay, so let's go ahead and take a look at another example. So say we want to find the inverse sine inverse of 0. So again, we ask ourselves, what is the angle that would give us the exact value 0? So we want to know sine of what angle gives us 0, making sure that theta, this angle, lies between negative pi over 2 and pi over 2. Another way you can think of it as the theta must be in this half of the circle, because this is pi over 2, this is negative pi over 2. So our angle must be on that half of the circle. So again, by drawing the unit circle, because this point we can find it on the unit circle, when is sine equal to 0? Well, sine, we know it's the y-coordinate of an angle. So this is when y is 0. So we have 1 comma 0. And we also had this one. This is negative 1 comma 0. But that's outside the boundary of theta, so we're not going to include that one. Only this is the one that will give us sine inverse to be 0. So sine inverse of 0 is going to be the 0 degree. Or you consider it 0 radiant. All right, so let's take a look at another example. So say we want to find sine inverse of 1/2. So what is that equal to? Well, again, we'll do the same thing. We want to find what is the angle for sine that would give us the exact value 1/2. And again, we want to make sure that theta has to be between negative pi over 2 and pi over 2. So from our special right triangle, we know that sine of 30 will give us 1/2. So therefore, this is going to be theta equals 30 degrees. Or in radians, we can say theta is equal to pi over 6. So that's something we studied earlier when we're looking for exact values. Okay, so sine of 30 degrees will give us 1/2. And this angle is within the range of negative pi over 2 and pi over 2. So that's good. All right, let's take a look at another example. So what if we want to work with a different inverse function? So we want to find cosine inverse of 1/2. Well, so now cosine is a little different from sine because cosine inverse exists within a different interval from sine. So we know we want to find cosine of some angle that will give us the exact value to be 1/2. And the angle has to be between 0 and pi. So that's the interval you have to consider if you're looking for cosine inverse, because that's where cosine inverse exists. So from our knowledge from the unit circle, we know when theta is 60, cosine is 1/2. So therefore, theta has to be 60 degrees, or in radian, that's pi over 3. So that will be the exact value for this problem. And we know pi over 3 is within this range, so that makes sense. Let's take a look at another one. So say we want to find the exact value of cosine inverse of negative square root of 3 over 2. What is that going to give us? Well, we want to know cosine of what angle gives us negative square root of 3 over 2. Well, we know this angle must be within the boundary of 0 to pi. Knowing that, that will help us to find theta. So we know on the first quadrant, so let's take a look at this one. This answer means cosine inverse has to be from 0 to pi. So it's the upper half of the circle. So knowing that, we know on the first quadrant, if I look at an angle, say this quadrant, we have cosine of some angle to give us positive square root of 2, square root 3 over 2. So we know the theta from the unit circle has to be pi over 6, 30 degree. So that's in the first quadrant. So this is pi over 6. But we want the answer to be negative a square root of 3 over 2, which means we can go to the second quadrant because on the second quadrant, cosine is negative. So therefore, we're looking for this angle because that will give us negative, this theta will give us negative square root of 3 over 2. So we want that angle. Well, we know that the angle on the first quadrant is pi over 6. To find the angle on the second quadrant, we will do pi minus pi over 6. So for quadrant 2, we know our angle is going to be pi minus the angle we know, which is pi over 6. And by common denominators, this would give us 5 pi over 6. So there you go. That's the angle on the second quadrant, which gives us cosine of negative square root of 3 over 2. So therefore, our answer to this problem is going to be, so maybe I should erase the question mark, cosine inverse of negative radical 3 over 2 is 5 pi over 6. And that is within this boundary that we have. So that makes sense. All right, so this is it. I hope this idea makes sense.